All right, welcome to part two, which is the backside of your review. And so let's see if we can get this part taken care of um, and hopefully understand these pretty well. So on the backside, we're starting with simplifying each expression by combining like terms. So I'm going to use my colors because I like to be able to tell the difference between different things. If you notice though, these all contain x. So I've got a negative 6x, a positive 4x, and then if I use that, I have a negative 3x. So basically, all I really need to do is add my coefficients, the negative 6, the positive 4, the negative 3. And I'll probably add negative 6 and negative 3 first to get negative 9. Negative 9 plus 4 gives me a negative 5. And we still have that label of x, so negative 5x. Moving on to number 10. Number 10, if I have a couple of different things. I have this 6a and negative 6a. They both have a's. Those are my apples. But then I also have some bananas, looks like. Okay, so I've got 2b and 5b. So when I put those together, negative 6a and positive 6a, those are going to cancel each other out. They're going to become 0. So really the only things I need to focus on are the 2b and the 5b, which is going to be 7b. And that's going to be my answer. There's no a's because they cancel out. And then for number 11, I see some parentheses. So before I can do anything, I've got to distribute. So I'm distributing here and here. If I take the 4 and distribute, I have 4x and then plus 8. Okay, and then I've got another set of parentheses. So really, I need to pay attention to that and do the same thing. So I'm going to distribute here and here. Notice it's not just 5, it's a negative 5. So when I distribute the negative 5 in, I have negative 15x. And the negative 5 times the 6 would be a negative 30. Now I don't have any parentheses, so I can use my colors to figure out what goes with what. So here's my x's. So those will go together. And then I also have some constants. So I have this just plus 8 and then negative 30. So if I put those things together, the 4x and negative 15x, I would have negative 11x. The positive 8 and a negative 30, well, I'm going to subtract them because one's positive and one's negative, so I end up with negative 22. So negative 11x minus 22 in this case. Number 12. Again, I have some parentheses, so I've got some distributing to do. So I've got to distribute here, and I've got to distribute here. So negative 2 times the 3x is going to be negative 6x, because negative 2 times 3 would be negative 6. Negative 2 times 5 would be negative 10 or minus 10. And then I still have this minus 4 that I'm going to bring down here. Well, now I've gotten rid of my parentheses, so I can figure out what goes with what. Here's my x's, and then the rest of it is not, those are constants, so they're going to go together. So if I keep my colors together, the negative 6x is by itself, so I'm just going to bring it down because we like to have the variable go first and then the constant. And then I have negative 10 minus 4, so that ends up, if I put those together, with negative 14 or just minus 14, because we don't like to put two signs like plus negative 14. We like to be lazy as mathematicians, so if I don't have to put two signs, I'm just going to put the one of negative 14 or minus 14. All right, moving on. Find the domain and range of each graph. So taking a look, remember the domain is dealing with our x value, and our x value moves left to right. So we take a look at the vertical parts, and I'm going to say that although it looks a little bit off, especially on this right side, that it's not tilted at all. So we have a boundary, a left boundary here, and we have a right boundary here, which means that X is trapped when we have those two. So X is going to be trapped in those values. So my domain, if X is trapped, I'm going to start with that negative 1, 2, 3, 4, because I go least on this side, greatest on the other, so the 2. I start with my less than, and then I need to determine, is it or equal to? Well, being that it touches and runs up and down those lines of negative 4 and 2, we are going to include the less than or equal to part. All right, so for the range, remember the range is moving up and down, and those arrows tell me they go up forever in one up direction, and it goes forever in the downward direction. So being that we can't put a boundary on there, we're just going to call our range all real numbers, because there is no boundary for that. Okay, so all real numbers on that. All right, let's take a look at number 14. So number 14, we have a start and a stop, which means that I have boundaries on both of them. So that means my X is trapped between negative 1, 2, 3, 4, negative 4 here. And we start with the less than X, and we have our less than. We have 1, 2, 3, 4, 5, a positive 5. They are filled dots, so I need to include the or equal to, so that would be my domain. As far as my range is concerned, well, my range has a starting and stopping as well. So there's a boundary here, and there's a boundary down below here. So when I go to write that, I start with my least value, which is negative 2. I'm going to have my less than. This time I have my y. Don't forget it's y dealing with that. And I'll put my less than again, and my upper boundary is 1, 2, 3, 4. And then I need to decide, is it going to be or equal to? And in this case, it is or equal to on both of them because they are filled dots. Okay, they are filled circles. And then number 15. Number 15, I have a starting point right here on the right. So I have this boundary here, but I don't have a boundary on the left. The only one I have is on the right. And so with that being the case, X isn't trapped, so X just comes first, and it's moving to the left, which means that it is getting less than. Those values are getting smaller than the 4, because our boundary line is on 4. So we're going towards the left, so it becomes less than. And it's just less than because that is an open circle, open dot on that 4. So we just leave it just like this. As far as the range is concerned, I do have one boundary, and it's going to be up here at the top because it never gets any larger than the 1, 2, positive 3 there. Everything else stays down below. And so that's where my boundary is. And then it keeps going on forever in this direction. So as a result, we have y, and it's getting smaller by going downward. So it's going to be less than, and it's 1, 2, 3. We need to decide if it's or equal to. Well, being that we're focusing on this right here and not the open dot, because it touches that line and includes that line, yes, it is or equal to. So our range is going to be y less than or equal to 3. All right. Towards the end of the night, the concession stand sold out every item except for 8 hot dogs. They have $135 in the cash register right now, and they earn as much money as possible by trying to sell those hot dogs for $3 each. What is a reasonable domain for this function? Well, first thing I would probably do is write my function. So to get my total amount of money, okay, so to get my output of total money, so f of x or y, you could say, I already have $135 in the cash register, so we know that we've got that money in there. And then the hot dogs we're trying to sell for $3 each. So if I take 3 times every hot dog, so if x represents my hot dogs, So 3 times however many hot dogs I have, and then add that 135, I end up with my function or my total amount. So what's a reasonable domain? Well, here's the thing. We need to determine, is this discrete or is this a continuous function? Well, X is our hot dogs. We're only going to sell so many hot dogs. We can't sell 1.5 hot dogs. So that means this one is going to be discrete. So a reasonable domain would end up being the amount of hot dogs that we could sell. So we could sell 0 hot dogs, we could sell 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 hot dogs, because that's all the hot dogs that we have. So that would be our domain. Then it asks, is $141 a reasonable range value? Why or why not? Well, here's the thing. We already have $135 in there. So to get to 141, we have some amount, and then we add the 135 to it. And so really $6 would be how much we would need. Well, 6 plus 135 is 141. So is it a possible range? Yes, because 2 times 3 would give us that value of 141. So we could sell 2 hot dogs, right? So 2 hot dogs at $3 each. Whoops, not sure why that happened. 2 hot dogs at $3 each would give us that $6 that we need. So is it a reasonable range value? Yes, because of this right here. 2 hot dogs at $3 each would give us the 6 that we need right in here to make that true. Is $160 a reasonable range value? Why or why not? Well, $160, if I take the 135 away from 160, so 160 minus 135, that tells me I have to earn $25 by selling hot dogs. Well, at $3 each, 3 times what gives me $25? Well, 3 times 8 is 24, but we need 25 to get exactly for 160. So is it reasonable? No. And that's because of the fact that 3 times 8 is 24, but we need to get to this 25. Okay? All right, and just to finish up real quick, so draw an example of a graph that does not represent y as a function of x. There are all sorts of graphs out there. We showed several on Monday's warm-up, or when we were going over some things before the task activity. But one of the things that you might do is, I know maybe you could draw a circle because it would hit more than once. I like to do one that looks like this oftentimes, because it definitely does not pass our vertical line test, because it ends up hitting. So that would be an example. Your example could look different as long as it shows that y is not a function, that y is not a function of x. Okay? And then it says draw an example, so number 20, draw an example of a graph that shows y as a function of x. So just an example of a function, there's all sorts of types. You could have a linear, just even this type, where we have it a horizontal line. You could have a linear line like that. We could have even something that looks like this, as long as it doesn't cross and things like that. So there's a variety of different ones, and every one of these would pass the vertical line test. All right, this is part 2. If you have other questions, I hope to see you and come and see me, and I can answer those questions.